to solve this simple example. If we have a circuit like this and we have a current source like this, so if I want to calculate I, the current will never change. Okay, current will never change unless you have a certain dividing point. Dividing point means what? Dividing point is a point that, for example, assume that you have a current like this moving, and then you have a dividing point like this. So if you have a current here, this current will be divided between these two branches. Okay, so if the current here, for example, is 3 ampere, this one and this one will be different. 3 ampere will be divided between two. That's it. But in this situation here, this current is continue 3 ampere, 3 ampere, and so on. Will remain 3 ampere, will not change. The current will not change. It is still 3 ampere. Then I is 3 ampere. I is 3 ampere. The current is 3 ampere. Yeah, this is I was talking about number 1 here, but it's okay. They are the same. The same here. This current is also 3 ampere. Why? Because there is no dividing point to change the current. The current is the same. Continue like this, and will remain 3 ampere. And this is a current source. I know that if we have a current source and it is 3 ampere, then the current is 3 ampere. For the third one, the current is 3 ampere because you have a current source. Then it will continue 3 ampere. It will not change. It will not change. So this I is 3 ampere also. 3 ampere. Okay. For the last one, if this I is 8 ampere, then the current is 8 ampere. Then I is 8 ampere. 8 ampere, right? Then the current is 8 ampere. Then now we know that the current is 8 ampere. Then it will continue 8, continue 8, continue 8, right? Then the current even in this source is what? Is 8 ampere. Also, will not change. There is no reason for the current to change. Okay. But what is this? This one is a current source also. It's dependent current source. What's its value? 2V0. It is 2V0, right? Then if 2V0, and I know that it's 2V0, and I know also that's 8. So 2V0 equal 8. This current equal 8. So if 2V0 equal 8, what is V0? It's 4. V0 is 4. 4 ampere. 4 volts, sorry. V0 is 4 volt. So again, this current source, the current here is 2V0. Okay? And I know also that this current is the same here. This current will change, not change. It is 8 ampere. Then 2V0 equal 8, which make V0 equal 4 volt. 4 volt. The last two definitions in this chapter are power and energy. Power and energy. So power is, this is a time rate change of energy. So power is dW by dt. dW by dt. Power is dW by dt, which is very simple. So when you see this was time rate change, time rate means d by dt. It is always like this. You remember when I said I would talk about the current? The current is not just charges moving, but the time rate change of moving charges. That's why when I said I equal what? I equal time rate change. Okay, when I said time rate change, it is d by dt. Okay, if what? The charge, so it's Q. It's Q. D by dt of what? Q. Here, this time rate change of what? Of energy. So it is d by dt of what? W. D by dt of what? W. So it is dW by dt. Here I can find the relation between power and voltage and current. How? By adding dq in the top and bottom, like this. You see, dq is in the top and bottom. So you can cancel each other. You can cancel them. So I did not change anything. It is still dW by dt. But now when you divide these two terms, dW divided by dQ is the voltage. From the definition of the voltage, dW by dQ is the voltage. If you remember, if you return back to the slide, it is dW by dQ is the voltage, and dQ by dt is a current. I just mentioned this is a current. Okay, so in this case, power equal what? Equal V times I. So if you want to calculate the power absorbed, okay, by any element or power generated by any source, all what you have to do is just to do what? Multiply the voltage across this element times the current. Voltage times the current will give you the power. What is the unit for power? It is in watts. Okay. What is the unit for power? It is in watts. Here it is. This is watts. This is watts. Oh, I'm sorry. Okay. This is watts. And in any circuit, when you add all the voltages in any circuit, it will be 0. That's normal because you always generate power and you have the elements that absorb this power. So in this case, when you add all the powers, some generated power, okay, are positive and the absorbed power are negative. When you add them, they must be 0. Okay. The energy, the definition of energy is, if you have energy, this means that you have ability or capacity to do work. That's it. So even this has no relation with circuits. The energy, you can say, is this ability to do work or capacity to do work. But if you are sleepy or you are tired, you don't have energy. You cannot do work. And it is measured in joules. Measured in joules. Okay. So this is the last, I believe this is the last slide. I don't know if this is the last slide or not. Oh no, I still have some one slide more. So for example, here, if I want to calculate the power for in this elements, here for the first element, what is the voltage? The voltage is 9. So voltage is 9 volt. What is the current? It's 2 ampere. Okay. Voltage is 9 volt. Current is 2 ampere. They are given. So what is the power? Power absorbed by this element is 9 times 2, which is 18. 18. What is the element? What is the unit? What's the unit for power? Watts. 18 watts. Second one, what is the power in this resistor here? The current is 5 ampere. Current is 5 ampere. I know this one because it is given. So again, there is no change. There is no reason for the current to change if you don't have any dividing point. Okay, so if the current here is 5 ampere, then this current will continue 5 ampere, will not change. Since the current in this element is 5 ampere. What is the voltage? The voltage between these 2 points, this one and the other point, the other terminal. What is the voltage? The voltage is 3 volt. Why? Because this element is connected directly to the 3 volt source. Okay, then the voltage between this point and this point is 3 volt. We know this. It is 3 volt. And this one is positive. This one is negative. 3 volt. This one is connected to this terminal. And this one is connected to this terminal. Then the voltage across this element is 3 volt. Okay, then you can write it here, 3 volt. Okay. So if the voltage is 3, the current is 5, then the power is 3 times 5, which is 15 watts. 15 watts. Look at the last one here. This is a current source. If you have a current source, then you know the current. You know the value of the current. So it is 3 ampere. 3 ampere. Okay. So this is 3 ampere. And the voltage is given here. The voltage is given. It's 5 volt. So the voltage is 5. The current is 3. Then the 3 ampere. Then the power will be 3 times 5 or 5 times 3, which is 15 watts. 15 watts. So this will be the last slide in this chapter. These are just some questions that you need to answer and submit it. You may scan it and submit it on Canvas. Okay, so this will be the first assignment for you. What is the definitions? What is the voltage current? What's the definition of this? Voltage, what is the voltage? The voltage is the energy required to move a unit charge from one point to another. So if you want to create current, you have to apply voltage. So what is this voltage? Is the energy. Energy. You exert energy to move a unit charge from this point to this point. This is what we call it voltage. What is the current? The current is the time rate change of charge. The time rate change of, you can say, moving charges. Moving charges. Power is the time rate change of energy. And what's energy? Is the ability or capacity to do work. What is the unit? The unit for voltage is volts. Current is in ampere. Power is in watts. And energy is in joules. You can also write, when you define, you can also write the formula for the voltage. What is voltage? Voltage is dW by dQ. dW by dQ. What is the current? Is dQ by dt. What is the power? Is voltage time current. You can say that. Or you can say dW by dt. dW by dt. This is better. dW by dt, because it means the time rate change of energy. What is the energy? You don't have formula for this. Energy is the ability or capacity to do work. So please, if you have any question, I hope that you watch this video before the live lectures, and in the live lecture, you are welcome to ask any question about this video. Thank you very much, and see you in the next video.